Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 81, Search in Rotated Sorted Array 2. Right, this is a problem that we've already solved, but we've solved the first version of it. So we've solved the original Search in Rotated Sorted Array. And we're given an explanation as to what this problem, what the problem actually is and how we need to solve it. And it's basically identical. We're given a list of numbers in ascending order. We're given, we're told that it's rotated. So it's rotated around a point. So it's, at a certain point it's being rotated. So, if we have, 1, 2, I don't know, 1, 2, 1, 2, 3, 4, 5, and then we'd get 4, 5, 1, 2, 3, like. So you're basically at the third index is where we are pivoting this list. So basically we have an array which is pivoted and we need to find a target. We're given a target, right? And we want to return true if it's in the list and false if it's not. And in the first problem, and when we solved it, we kind of discussed that there are ways to do it, and we were told to do a big O of log n in big O of log n time. So that is the most optimal solution for that problem because we were using binary search on its own. And we could say let's solve this problem by doing a linear search. Let's just scan through the entire list. It'll be a big O of n time, but we'll get a solution. It's not that bad. But relatively speaking, we can do a lot better, right? So we want to use binary search. So you might say, what's the difference between with this problem and the first problem? Well, the first problem is basically identical, except for the fact that there are duplicate numbers in this array, and in the first problem that was not the case. Okay, so we're given some examples, but really it's important that you kind of go over the first problem and understand how to solve that, because the code is pretty much exactly the same except for one case, right? And actually, I'll tell you what. Let's go through an example of how we solved the previous question. So the previous search in rotated sorted array 1. Let's say this example that we had and we used. And let's say we're looking for a target of 0, and our midpoint is over here. So that's our midpoint, 7, and we are looking for the 0. So we're going to say, is 0 less than 7? Yes, it is. Well, then typically, traditionally we would look on the left-hand side now, but we also compare the value of the left pointer. We say that's greater than the target value. Therefore, we want to look on the other side, on the other section, second portion of our rotated list, because it's not going to be in the first one, it's going to be in the second one. So that's basically the intuition behind basically solving the core crux of the problem, if you were. But the edge case for this problem is we do have duplicates. So we could and this is basically the case that we need to modify our code, our original code to handle. So let's say we have this list over here, right? We've got 2, 2. I'm just going to put a bunch of 2s, 3, 2. Right, so we have a bunch of 2s, and this is our list, and we could very well be given a list like this, or end up after a couple of binary search operations where we've split the list into 2, and now we have a much smaller list, and we're left with a list that looks like this. Well, this is our midpoint, right? And we are at a bit of a conundrum, so because look at this. We end and we start this list with a 2. So we have no idea, we can't just look at, is our midpoint greater than the left point? That doesn't work here because they're both exactly the same. So there's no way we can actually know which side is a left-hand side and which side is the right-hand side. It's easier from a human perspective because we can just look at it with our eyes, but for our computer program, there's no way it will know which side is left and which side is right. So what can we actually do? Well, we can kind of use the intuition behind the fact that if this is 2 and the midpoint is not equal to the target, well, then this is the same as the midpoint. Therefore, it will also not be equal to the target. Then there's only one thing we can do, right? And that one thing is our left pointer we increment it by 1. That's the only thing we can do, is increment our left pointer by 1 and basically shorten this list and then create basically a new, find our new midpoint, and then so on and so forth. So you'll basically want to keep the code pretty much the same, but the thing that we want to do slightly different is consider the case where we don't know if we are in the left or right hand side of the array, in which case we just want to increment the left pointer by 1 and then do binary search again. So let's get into coding this. Length of nums minus 1, actually, and the left pointer is going to be 0. So let's get our left and right pointers there. And the next thing we want to do is say while the left pointer is less than or equal to the right pointer, the midpoint is going to be equal to L plus R divided by 2. So now we've got the midpoint. Now, if the target is equal to the number at the midpoint, well then, we can just return true. Because that's what we want to return. We return a Boolean true if we find it, false if we don't. Otherwise, we want to have a look at the left-hand side, right? And how are we going to do that? Well, we're going to say if the number at the midpoint is greater than the number at the left pointer, we are in the left-hand side. Otherwise, if the number at the midpoint is less than the number at the left point, we are at the right-hand side. Otherwise, we have just found we're in a duplicate condition where we don't know which side is left or right, so we just increment our left pointer by 1. Okay, and now we just need to finish out the core, the other two cases, the main two cases from our original problem. And then we're going to just say if target is greater than the number at the midpoint, or the target, we need to look at the left-hand side, or we need to swap sides where we look, right? So we want to look on the right-hand side now. So we're going to say if the target is less, actually on the left-hand side, if the target is less than L, we're going to set left point equal to mid plus 1. Otherwise, we'll set this to R equals mid minus 1. So that's the case for the left-hand side. And then we do have the right-hand side as well. So we'll paste this code over here. And we're going to say if the target, instead of being greater than, now if the target is less than the number at the midpoint, or the target is greater than the number at the right pointer, we want to swap these around, right? So we want to say R equals mid minus 1, L equals mid plus 1. So that's the core functionality over there. If we finish our while loop, if we finish our binary search, and we don't actually find a result, or we don't return true, then that means our number is not in the list, so we just return false. Now let's submit our code and check that works. And it does not work because we are not comparing something properly. Okay, so we're saying this should be nums L and nums R, actually. Don't know why that was like that. Okay, and now all our test cases pass for this problem. So yeah, basically pretty much identical to the first problem. I kind of went in depth in that video, so I definitely would recommend watching it out. This is the kind of code which is pretty much identical. We just have this edge case over here, which considers the fact that we could be in a position where we don't know which side is the left or right portion of the list. So with that being said, guys, let's look at the time complexity. Well, time complexity is going to be big O of n. It would be big O log n, in best case scenario, but if not, we want to have a more accurate worst case scenario, which we choose for our time complexity. So it's going to be big O of n. And space complexity is just auxiliary space, so it's going to be big O of 1. So with that being said, guys, I hope you enjoyed this video, and I'll catch you in the next one.